Hi everyone, welcome to my YouTube channel, and for this video we will talk about given a grid like 9 by 9 grid, we have to determine whether this is a valid Sudoku or not. So I just want to emphasize that this is not, so for this problem we are not trying to come up with a Sudoku solver. We just want to know whether a given input is valid Sudoku or not. So this problem is not too difficult. So let's look at the problem statement. So here is the problem statement, and as you can see, it looks a little bit confusing. Like, what do you mean by the valid Sudoku board? It means that, so if you look at this one is actually true because notice that 5, 6, 8, 4, 7. None of those numbers are the same, so they are all unique numbers. 5, 3, 7. So on, and we don't care about this empty blocks, so just forget about them. And same thing for the second row, 6, 1, 9, 5. Well, you don't see any repetition. For the second column, 3, 9, 6, you don't see any repetition. And we also look at this block, 5, 3, 6, 9, 8, so no repetition, so this one is fine. But this one is actually false because you look at this, we see 8 here and we also see 8 here, so this is false. So just want to emphasize that for this problem we are not required to come up with our own Sudoku solver. That's for the next problem, and I will talk about it in the next video. The way I did it is I basically had 3 like 9 by 9 grid, so matrix, and for each one, so the first one is for the rows, second one is for the columns, and the third one is for the blocks. And it may not make sense, but just bear with me. So notice that I mentioned this before, so we notice that for this row, so the fourth row, we have 8 and 8, so we have a repetition, and that makes this Sudoku invalid. And notice that here for this column we see the same 8 here, 8 and 8, so that makes this Sudoku invalid. So we somehow have to keep a record if the same number exists, and so I chose 9 by 9 matrix, and 3 of them actually. So for rows, columns, and blocks. Blocks means like this inner 3 by 3 matrix grid. So this one I call that like 0 block, for 1 block, like second block, third block, fourth block. I'm using the 0 index, so that's for this. And let's look at the next slide. So we need to, let's say we check the column first. The order doesn't matter whether you check the column first, the row second, or the the inner block the third. The order doesn't matter which one you check first. So let's see if we check. So let's look at the case where we check the column. Now we notice that 5, 6, 8, 4, 7. 5, this guy. Well, so the first entry we encounter is this 5, and this is our all these numbers are in our first column, so 0 column, and that will be mapped to this guy. Here we have 5. Well, 5 is so, and then we look at the first row here, and we see that 5 is not there, so we set that equal to 1. So for instance, if we have say board of 0, 4, that would be this guy 4, and we check if we have already seen it. If not, we set that equal to 1, so that 4 corresponds to this guy, and then we set that equal to 1. If this is say 4, then we check if board of 0, 4 is 1 or not. In this case it is 1, so we return false and we exit the while loop. We exit the the for loop. So that's basic idea for this problem. Here same for the row, we will be looking at this, and we notice that, so in this case we look at the board of 0, 1, and which is 3, and we look at this guy, we look at the first row, and we see if it is 1 or 0, right? If it is 1, that means we already have seen it, so we return false. Otherwise we set that equal to 1, and then we keep iterating to the right. And so that's what's going on here. So this 5 is for this guy. This one, the second entry, is for this guy, right? And then the last part is tricky. This board, like this inner 3 by 3 matrix. So I just call this guy the zero matrix. I mean 0 square, 1 square, 2 square, 3, 4, 5, 6, 7, 8. Okay. Now we look at this one. So all the entries here will be mapped to the first row. So there's gonna be 0 row, and 3 is for this guy, 5 is for this guy, 6 this guy, 9 this guy, 8 is this guy. So we see the idea, and the tricky part is how do you come up with this the mapping, like viable mapping from like this guy to this guy. Say for instance we will be given a coordinate. So in this case for this one 6, there will be what 1 comma 0, right? So 1 comma 0, and then how should we translate into this guy? There will be 0 comma 5, right? So that's the key for this problem. And how should we do this? So my approach for this was come up with this, and you can try this. You can try say this number and see where it lands. So this one will be what? There will be 6 comma 6, right? And we notice that 6, and we have this one, so there will be 2 times 3, there will be 6, plus 6 divided by 3, there will be 2, so we get 8. So we will be right here. So that works. So notice that for this one, for this problem, for this guy, we had 1 comma 0, and you plug 1 into row, 0 into column, we get what? We get 0, right? So we get 0, so that's good. And then the 6, this one is, we are using the 0 index for like this guy, so it will be 6 minus 1, that is going to be 5. So we will be at 0 comma 5. That's basically the whole idea behind this problem, and let's look at the code for this problem. So here is my code for this problem, and the only thing that you have to pay attention is like this part, and I think the other part is pretty much self-explanatory. Because we are given a string, make sure you don't forget that we have to turn it into integer, and then we have to subtract it from 1, because we have to consider that so all these numbers are starting from 1, and then our index is our array, the matrix is 0 index, so we have to subtract that from 1. And yeah, if it is, so we are given this one for empty block. If it is this guy, then we just we have this continue here, so we move on to the next iteration. And let's run this. Alright, so that's for this problem, and the next problem will be where we have to actually solve a Sudoku, and that one is a little bit complicated than this one. I will have a separate video on it, and if my video helps you guys understanding this problem, please give me thumbs up and subscribe to my YouTube channel, and I'll see you next time. Bye bye.